Good day. I am John Paul Ardenio, and now we are going to discuss about how to calculate doses in different situations. Let's proceed to problem number 1. Here we have problem number 1, which states that an intratracheal suspension for breathing enhancement in premature infants is dosed at 2.5 ml per kilogram of birth weight. So, how many milliliters of that suspension should be administered to a neonate weighing about 3 pounds? So here, 3 pounds is the weight of the neonate and 2.5 ml per kilogram is the dose. So, how do we calculate the dose of the neonate given that the dose of a premature infant using ratio and proportion? So, that's the question here. So, what is the first thing we will do? First, we need to identify what unit is asked in the problem. So, here in our problem, we are asked for how many milliliters. So, next, in order for us to calculate the dose of the neonate based on his or her body weight, we need to convert the given weight in pounds of the neonate into kilograms. So here, as you can see, it's 3 pounds. We need to convert that to kilogram in order for us to get the dose of the neonate based on his body weight. So, let's convert that one. So, conversion. 3 pounds is multiplied to 1 kilogram, wherein this 1 kilogram is equals to 2.2 pounds. So, pounds here will be cancelled out, and 3 will be multiplied by 1 and divided by 2. And that will give us the answer, which is 1.36 kilogram. So 1.36 kilogram is the weight of the child in kilogram. So next, since we have now the weight of the child in kilogram, we can calculate now his or her dose based on the given dose. So, the given dose here in our problem is 2.5 ml per kilogram is equals to x. Why x? Because x is what we are going to find. We are tasked to find on how many milliliters of suspension do we need to administer to a neonate weighing 3 pounds. So that's why we put here x. Given that the weight of the child is 1.36 kilogram, where we are able to solve that earlier here. So just substitute. Next, always remember the rule in ratio and proportion is cross multiplication. So cross multiply these values. So x multiplied by 1 kilogram, that would be 1 kilogram times x, and 2.5 multiplied by 1.36 kilogram, that would be equal to 3.4 ml over 1 kilogram. So, both sides will be divided by 1 kilogram in order for us to cancel this kilogram. And what's left now is the ml, which is the value or the unit that we are tasked to find here. So, the answer for that is 3.4 ml. So that's the volume of the suspension we needed to administer to a neonate. Now, we have problem number 2, which states that the daily dose of diphenhydramine HCl for a child may be determined on the basis of 5 mg per kilogram of the body weight or on the basis of 150 mg per meter squared. So we are tasked to calculate the dose on each basis. Remember, on each basis. For a child weighing 55 pounds and 40 inches in height. So, what is the first thing we will do? So first, we need to do is to convert the given weight for us to calculate the dose of the patient. So, 55 pounds, which is given here in our problem, will be multiplied to 1 kilogram, wherein that 1 kilogram again is equals to 2.2 pounds. So, pounds here will be cancelled out again, leaving kilogram as our unit for weight. So 55 multiplied by 1 divided by 2.2 pounds, that will give us the answer 25 kilogram as the weight of the child in kilogram. So next, since we have now the weight of the child in kilogram, let's calculate the first dose of the patient for the first basis. So what is our first basis here? 5 mg per kilogram. So first basis. So 5 mg over 1 kilogram, that is equals to X over 25 kilogram. So X here is expected as milligram later. So 25 kilogram is the weight of the child that we solved earlier here. So that would be cross multiply again here. So that would be X times 1 kilogram, and 5 multiplied by 25 is 125 milligram over kilogram. And multiply both sides or divide both sides by 1 kilogram in order for us to cancel out this unit. And that will leave milligram as the unit alone. So now, we have the answer, which is 125 milligram. So that is the dose for our first basis, which is 5 milligram over 1 kilogram. So let's proceed to the second basis. Still the same, we have the same problem, but for now, we are tasked to solve for the second basis, which is 150 milligram over square meter. So, for the second basis, we need to first to find the body surface area of the patient before calculating the final second basis. So, since we have here the weight of the child in pounds and the height of the child in inches, we are able to calculate the BSA of the child. So, the given formula for BSA is BSA is equals to square root of I, which is your inches in height in inches, and P for weight in pounds over the constant 3131. So, what's next? Simply just substitute each value from the problem. So here, we have 40 for the height of the child in inches, and 55 here for the weight of the child in pounds over 3131, which is constant. So first thing to do is just multiply 40 by 55 and then divide that value by 3131. And the quotient will be calculated again by finding its square root. So the square root here, the answer here is 0.838 m squared. So this is the body surface area of the child. So what's next? Now we can solve for the dose of the patient based on the second basis, which is the 150 m squared. Second basis. So the formula for the second basis, we will use the patient dose is equals to BSA of the child in meters squared multiplied by the dose in meters squared, per meter squared. So, simply just substitute each value from the given and from the BSA we solved earlier. So, here is the calculation or the solution. BSA of the child is 0.838 meters squared. Here, we solved that earlier. Multiplied by the second basis, which is 150 milligram per meter squared. Simply just multiply each value for us to get the second dose. So, here, the answer is 125.7 milligram, or that would be equal to 126 milligram. So that is the dose for the second basis. That's it. Now, let's proceed to problem number 3. Problem number 3 states that a prescription calls for 2,000 milligram of amoxicillin just for one dose. If the pharmacy only carries 250 milligram capsule of amoxicillin, so the question here is, how many capsule will you need to fill this dose? So simply, just substitute the value given in a ratio and proportion format. So that will be 250 milligram over 1 capsule. That would be equal to 2,000 milligram over X. So X here, we are tasked to find on how many capsule we are needing in order for us to fill this dose. Just cross multiply again. So that would be 2,000 multiplied by 1 capsule would be 2,000 milligram in each capsule, equals to 250 times X. So next, just divide both sides by 250. So that would allow us to cancel this unit. Then what's left is the capsule. So the capsule here, that would be equal to 8 capsule. So that's it. We need 8 capsule of amoxicillin in order to fill this dose. Now, let's solve for our problem number 4. So problem number 4 states that if the adult dose of a drug is 750 milligram, then what is the dose for a child weighing 25 pounds? So based on the given provided, which is the weight and the adult dose only, we can say that we need to find the dose using Clark's rule. So what is the formula for Clark's rule? So the formula for Clark's rule is weight in pounds over 150, which is our constant value here. That would be multiplied to adult dose. So what's next? Next step is just simply substitute each value given in the problem. So here's 750 and 25 pounds is what the value that is given in the problem. So Just substitute. So the patient dose would be 25 pounds over 150. So weight in pounds of the child, 25 pounds. Over 150, which is our constant value, and then multiplied by 750, which is our adult dose. So first step, just divide 25 pounds by 150, then the quotient will be multiplied to 750 milligram. So the product is 125 milligram, which is our dose for the child weighing 25 pounds. Let's proceed. So the last problem states that calculate the dose for a 3-year-old child. An adult dose of a drug is 500 milligram. So we are tasked here to use Young's rule. So what is the formula for Young's rule? So the formula for Young's rule is age over age plus 12. That would be multiplied to the adult dose. So it's simple. Because the given here, 3-year-old, that would be directly substituted to the age, and the 500 milligram, which is the adult dose, will be directly substituted for the adult dose formula. So here's the substitution. 3 years old over 3 plus 12, wherein 12 is constant here and 3 here is the age of the child. That would be the sum of 15, a sum of 15. So 3 divided by 15 multiplied by 500 milligram, which is the adult dose, that would give us the answer 100 milligram as the dose of the child using Young's rule. So simple as that. So that's it. Thank you for listening. I hope you have learned something.